Hello, hello, hello. Welcome to our stream.
Hello,
So,
hello, hello.
अभी
Welcome
हम
to our stream. Hello,
so
hello, hello.
अभी
Welcome
हम
to
we
our
are
stream.
waiting for people
So,
to join,
abhi hum
and we'll have a great
we
fun.
are
We'll
waiting
talk,
for people
and
to join.
let's see,
And
let's
we'll
see,
have a
let's
great
see
fun.
how many
We'll
people
talk
join.
and people to join.
I am
Let's see,
very
let's see,
excited
let's see how many
that
people
we are
join.
talking to
And
people,
I am very
and let's
excited
have some
that we are
amazing
talking to people.
conversations. Let's see,
And let's
let's
have
wait for
some
people join.
amazing conversations.
And
Let's see.
yes,
Let's
thank you
wait
for a
for
like,
people
bro.
join conversations.
And
Let's see.
yes,
Let's
thank you
wait
for a
for
like,
people
bro.
join conversations.
And
Yes, thank you for a
let's see
like,
if
bro.
people join. Meanwhile, the whole point of
Let's see
this
if people
streaming
join.
is let's
Meanwhile,
have very
the whole
interesting
point of this
discussions
streaming is
about
let's have very interesting
what
point of this
you know
discussions
what are we
about
missing.
have very
There are
interesting
lot of
what
things we need to
discussion.
uh, no, we have to find, we have to discover in this universe, but we need to have a greater understanding of how do we approach the problems, right? So that is why we want to make sure everyone is, have a right mindset to reach the problem, like, attack the problem. So what is the right mindset? I might have an opinion on that. You might have a different. Well, the most normal thing to do is go with the scientific method, but community discussions are equally important. So that's what we are going to do, and let's wait for more and more people to join. Uh, Someone is watching. Welcome. I hope uh, you are ready to have some good discussions. Any question, anything on your mind, any idea you might have right now? What do you think we'll discuss? Let's see. Meanwhile, let's see what we can find, what good topics we can search and talk about. And, mm, oh, we have a message. So someone is saying, how about discussion on space related stuff? Of course, like, the background is about space, so it makes sense. And definitely, we'll have a discussion. Let's just wait for a few more people to join, I guess. And oh, live chat. Cool, 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 cool. Let's see if more people are joining. Meanwhile, I'll search if my friends are joining. And hey, Okay, let's see who are coming. Meanwhile, we'll start, you know, having start searching something. So one of the suggestion is let's discuss something on space, right? Oh, sure, why not? Let me just search something and make little bit of adjustments. What do we talk? What do we talk? What do we talk? Hmm. Formation of black holes, I guess. Formation of black hole. Black holes are typical black hole basics. Hmm. Black holes are among the most mysterious cosmic objects. Much studied and understood. These objects aren't really holes. These are concentration of matter packed into tiny spaces. That makes me think. The concept of white space is white hole is really fascinating. Like it's just a mathematical concept, but to think about that, if something is sucking in stuff, something must be throwing out it. So that creates the idea of a wormhole. But then still, the question is rather not whether it's because there's one theory, right, where we say uh, that black hole might have a universe in itself. If that is true, then where is the stuff coming out from white hole? Well, there is no proven record about white hole being noticed, or it's just a mathematical concept. But just still, if you think about it, what do you think white hole does it make sense? I don't think it makes sense. Like, which universe is throwing stuff out of itself, right? So that kind of breaks the system. Oh, I'm showing myself, I guess. That's not what is required. Mm, uh, mm. So, any in and also in the movie Interstellar, this they kind of say that black hole is a wormhole is a three-dimensional space where you enter and in one place you exit at one place. Then, if black holes are wormholes, then everything should have been sucked in the Interstellar to the other place where it was throwing out. No, I don't think that is, or maybe I am wrong. Let's just say, is black hole really wormhole? Not necessarily. While some mathematical equations in Einstein's theory of general relativity describe black holes as connecting to other regions of space via wormholes, real and naturally occurring black holes do not act as traversable. Okay, that also means that probably wormholes are different. Any proof proof of every proof of what? Any proof of not Mahabharata, not Ramayana. Any proof of wormhole? Yes. No, there is no observational. That is kind of obvious. Like, if black hole were discovered, it would have been a great, great discovery. And we're still waiting for more people to join, I guess. Huh. Hmm. But you're right, kind of. Like, it's an interesting stuff. What do you think? Any ideas from your side? Any opinion from your side? Any facts that I don't know yet? Mm. Oh, we have a chat button. Let's talk about new stuff. I guess that makes sense. So, what else? What else? Okay, new research in physics. Let's move with physics right now. And recent breakthroughs span quantum scale to deep space. Okay. Browse current research, physics, latest. Oh, let's see what nature is saying. Nature is pretty credible. Optic filters sort light by its quantum statistics. Okay. Magnetic field maybe. Magnetic field maybe. That is kind of an odd. That is kind of an odd topic for research paper. Uh, Triton likely originated from Kuiper belt in the outer solar system before Neptune captured it. Heating, for example, what is Triton? Is it an outer planet? Triton beyond Neptune. Triton is the largest. This is Neptune's largest moon. Okay, but it was not born there. Astronomers believe Triton is captured world by that originally found beyond Neptune in icy Kuiper belt. Uh, Kuiper belt. What is Kuiper belt? Now we'll search for Kuiper belt. Kuiper belt is massive donut-shaped region in icy bodies in the outer solar system. Okay, extending beyond, uh, extending from just beyond Neptune's orbit, about 30 astronomical units or AU from the sun. Okay, so what is saying that Triton likely originated from Kuiper belt in the outer system before Neptune captured it. Heating, for example, during the capture process might have produced a metallic core and potentially also a liquid ocean near the surface. In their model, Tilke and colleagues assume that Triton's inner structure consists of an equally fully liquid metallic core. Okay, so something about, but we don't have access because it's 27.99 euros and we don't have money. So let's go for something more interesting topic. Measuring the high energy neutrino sky using Deep Valley Neutrino Observatory, TAMBO. Hmm. I study on three-dimensional stress characteristics, the original performance setting. Okay. Machine. Guys, if you're watching, keep commenting so that we can have a proper discussion. Yeah, it's more fun, when it's have a, like we all say something, we all discuss. It's just, alone. It's just very the 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 fun of discovery is when you share with anyone. You know, we together, like we understand how significant each discovery is. That makes a huge difference, right? So keep commenting if you're watching, and yeah, meanwhile we'll continue researching things. So let's see if anyone else joins meanwhile. Research in only, let's see, New Journal of Physics spotlighting exceptional research. Let's see, exceptional research. Oh, sorry, not this. We'll probably cutting the tail of a photon. What? So removing a mirror while
So
single photon
removing
is
a
in
mirror
the while
so
single photon
removing
is
a
in the
mirror
the process of reflecting creates a quantum state of countless photons. So I'm not able to understand this. Does anyone else understand this? I am still trying to read. The researchers imagine a photon with single peak populating. Ah, what are the fancy? Huh, forget them. We focus on, yeah. So researchers imagined a photon with a single peak propagating from left to right toward mirror. Only when only the photon's leading slope has encountered the mirror, uh, and is now propagating leftward, the mirror is removed. Intuitively, one might suppose the photon might simply split in two, with the unreflected portion of the waveform continuing rightwards. Or thinking quantumly, maybe the mirror's removal creates a superposition of left and right propagating photons. Rukan and colleagues predicted a stranger outcome that arises from a rule within quantum field theory. The waveform of a single photon cannot have a sharp edge such as would form if mirror vanished abruptly, but a superposition of multiple photons can have such an edge. And the sharper the edge gets, the more photons are super. How do more how do more photons come from? I don't know. There is The researchers modeled this phenomena using so-called Bolokov transformations, which result from time-dependent change in quantum field modes uh, caused by removing the mirror. This removal exerts a tug on the quantum field which pulls just enough photons out of it. I don't understand this. I don't understand. Like this. This is saying that this removal exerts a tug on the quantum field, which pulls just enough photons out of the vacuum to form a suitably sharp edge. For an instantaneous removal, expected photon number raises to infinity, but for a slower, oh, someone is replying. I guess I should put it on silent. Yeah. Okay. Interesting research. Uh, you guys have seen, you are seeing the uh, page I'm looking at. If you find it out, just please comment on the video after it is posted. What do you find? Because I don't understand the superposition part. They are saying that it's the remove mirror is abruptly removed and the vacuum energy just comes out of vacuum. I can understand the vacuum is never a true vacuum. There's always pseudo particles or temporary particles, something like that, are always there. So and if a photons are made out of that energy, virtual particles, or I think it's called virtual particles. So if a photon is made using that energy, might be, but you guys can definitely shed some light on this one, right? So, okay, so we will see what other interesting things are there. Unraveling the topology of knitted fabrics. Entanglement goes steady as simple charge for timing. Plans for moon-based gravitational wave detectors get a lift from geology. Oh, that sounds interesting. Let's see. So, plan for moon-based gravitational wave detectors. You know, I have read that paper on that. I think gravitational wave paper. I don't
That
remember what was the name, but in US there are two places where they first sense the gravitational waves. And it was a very interesting experiment. You know, I'll tell you how. From what I remember, what they did was that they sent two lasers like this in cross way, and those lasers, the sources of these lasers were also fixed so precisely that all the unnecessary noise was absorbed, so that they are extremely sensitive, right? So the lasers were pointed out like this, and they came back from a mirror. No, both lasers has straight paths, and those paths were very long, like, I don't know, half a kilometer, 2 kilometer. I don't remember properly. But those lasers were reflected back by mirrors, and how they sensed it when gravitational waves came, they were completely precisely balanced. And when the gravitational waves came, they kind of, the balance kind of broke. So that is what now they got some waveform of a and some kind of wave, and similar waveform was found in another similar testing facility. I think, I don't know, halfway across the country. Funny thing was that both were opposite of each other. For example, the waveform of one side was mirror of other side, because of how they were aligned in some way. Please correct me if I am messing up the exact technicality. But when they mirror it back, the superimposition was remarkably similar, and that's what proved the presence of uh, gravitational waves. So it was really interesting. Now, if they do that in space, see, the issue with space is that materials has to be extremely exotic, and not exotic is not a right term for when we are talking about science in a scientific way, but uh, in vacuum the materials don't stay. They start vaporizing. They start some materials are uh, they start outgassing. So, and moon does not have its own. Moon does not have its own atmosphere. I don't think there's even minimal air or anything to create any kind of pressure. So the materials are going to outgas very badly. And let's search now. What is the pressure? Pressure. Oh, what is the pressure on moon? 10 to the power minus 15 millibar. Milli, no, not millibar, bar. Still, that is 10 to the power minus 12 millibar. This is extremely low. The materials are going to outgas so bad. That is why they have to use this. Just increases the cost of the project too much. How are they going to do it? Moon like massive object. Oh yeah, this mask is sometimes sticks to your skin. This skin scientists have proposed researching such gravitational wave responses by placing seismometers on moon surface. A new study led by Li Jiang from China's Institute of Geology suggests that the signal may be stronger than expected, especially in a region of far side of the moon where the crust is relatively thick. How it's related to geology? Gravitational waves can generate seismic waves in Earth and other bodies, but signal is typically drowned by vibrations from volatile weather pattern. Oh, okay. So atmosphere is something sloshing oceans, plate tectonics. Lacking those confounding sources, the moon is seismically quieter. Okay, that's definitely a geologic based solution. Lunar gravitational area seismometers. Okay, those studies assume uniform spherically symmetric moon. Of course, moon also has its ups and downs. And Jiang et al. Everywhere you find Jiang et al. Jiang et al. Is doing all kind of research. He's modern day Newton. Okay, Jiang et al. And you not really Jiang et al. For sure. He is more. Jiang et al. Is modern day Newton. He's into chemical engineering. He's into aerospace engineering. He's into uh, what is called biomedical engineering. Not just biomedical. He's in physics, chemistry. He's great. He's even greater than Newton itself. The Einstein who? My boy Jang is smarter than everyone. Okay. Kudos to you, Jangatal. We'll move forward in the meantime. And what else we can read? Okay. A blueprint for quantum simulator made of helium atoms. Bro, we are too far away from what people are doing. I might have to read the research people are doing and get context where does it even come from, because what do you mean a blueprint for a quantum simulator made for helium atoms? Like, out of the complete title, Uh, It's not making sense to me. What even they trying to do? Blueprint for quantum simulator. Quantum simulator. What is a quantum simulator? Quantum simulator, as in if we say quantum simulator, uh, they are trying to simulate what happens in quantum environment made of helium atoms. Where helium atoms are definitely stable and very small. So I guess we will read this one little bit. And uh, the diagram is pretty simple considering what they just said. Makes sense. You know, the more
What they just
complicated your
said.
research is, more simply you have to put it so that people actually understand what you are trying to say. New theoretical work indicates that the array of helium 3 atoms could enable more complex quantum simulations. Helium 3, what is helium 3? Helium 3 is rare stable isotope of helium with 2 protons and one neutron. 20 million per kg. $20 million per kilogram. $20 million per kilogram. That is how much for a gram? Uh, for a person with science background, seems like a difficult calculation. $20 million per kilogram. How much is a gram? Yeah, I forgot how to calculate. $20, $20,000. $20,000 for a gram. Okay. Now, how much you need is the main question. Physicists orchestrate and calculation interactions between individual neutral atoms in arrays to simulate what other quantum systems. Uh, you guys also try to read what they are saying. Uh, uh, reference is G. Lee et al. Okay, that's a summary. Let's see summary. Physics orchestrate and interaction between neutral atoms in array to simulate another quantum system. However, the atoms can only encode information as long as they remain coherent, which limits the complexity of the situation. Interesting. Uh, oh my God, the vital question just replied yo. Yo to you too. I hope you're having fun. If exploring new researches. See, I wanted to discuss how we have a how the what do we say? I want to discuss how it is important to have discussions on on the ideas of research and all that. So right now we don't have as many viewers, so and not many comments. So let's just focus on new researches, but we'll discuss more and more as because we're going to stream every day, and we will Have fun. Okay, okay. To state limits the moving atoms faster to getting more operational. Okay, this is something not interesting. But the main thing is that you know we think normal people when they discuss these things, some many of them call them nerds, nerds. But I think we guys should have more discussions. We need more discussions on a day-to-day life. You are you go to departmental store, you want to do small talk with the cashier, have a scientific discussion with them. Hey, I am buying milk and I am buying this cheese, and that latest discovery on the uh, helium atoms quantum simulator made of human atoms is very interesting. And you're like, oh really, I haven't found it, I'll share it with you, can you have my number? Oh, that's it. Now that is a pickup line which is not creepy, right? So now you have great pickup line, you have a great small talk, and it might turn into a big talk, right? And that's what you want. But make sure you make sure that the other person is also interested. Otherwise, you will be caught not again. Okay, let's do new research in mathematics. It may seem simple, but for normal people, but trust me, math research is crazy. You'll be like, what the hell? What are they even talking about? Math news. Let's see what math news is. Okay, we have to verify now. Yes, I'm a human. Huh? I'm failed? What? I'm definitely a human. I might look like a robot. Okay. Statistical test helps judge the value of personalization. Yeah? Okay, researchers develop AI tool that finds equations behind complex systems. Okay. Free text answers and LLMs reveal hidden reasons behind human choices. Now, this is something we'll read. Bro, I'm human. Okay. Why do people make choices they do? Researchers from Center Nervous Systems at TUD, Dresden University of Technology, the Max Planck Institute for Human Development, and the University of Basel present their new approach of finding answers to that question. The approach combines observed choices with participants' their own description of the decision process. Well, there's always going to be biases in that if you are going to ask participants, because I feel a lot of people behave in a certain way, but when they're asked to describe what you did, they describe it slightly different. But I think they will be taking that into account, allowing researchers to study human behavior in great detail than is possible with behavioral alone. The team merged behavior experiments with free text explanation to uncover the reason underlying humor, turning explanation. Our understanding of human behavior, including what is the conclusion? What is the conclusion? The combination of verbal reports, LLM, and rigorous mathematical modeling clearly demonstrated that people's own insights are valuable source of data. Okay, so I'm proven wrong that people have biases. Apparently, what people say is the best source of data. It also showed that the reason people rely on are not fixed but shift dynamically with structure of the decision problem. Many important decisions from financial planning to medical choices to social technology use policy, they cannot be fully understood from observing choices alone. In such settings, people's own explanation may be valuable. Oh, I did this because I was thinking this. I mean, Until unless they have they until unless, this summary is so vague. It's like saying, oh, the rocket works because some complex processes happen inside the rocket. Oh, we know what processes. Huh, not fun. Visual map of 20,000 words reveal why lip readers confuse common local. Huh? Fun on its own. New research, University of Kansas uses network science to determine why people make mistakes when lip reading. Oh, that reminds me of a lip reader who was a fraud and wanted, and she got a job of sign language. Those people who there's a report, there's something going on, a live revelation by police department that this happened and that happened, and that person instantaneously, simultaneously uh, converts them into sign language for the viewers. That woman itself was a fraud, and she was probably saying bullshit stuff too. So co-authors created a visual map of about 20,000 words in English and hoping to get better grasp why some words are more difficult to lip read. Okay. Uh, what we looked at the study is how people basically read lips and how accurately they are. See, a lot of this, gets confusing because some people do not open their mouth completely. For example, someone, specifically people with some accents, like, this one, uh, I don't know, it was which show. Some actress said that she was a British actress, and when she works in American movies, she has to use all of her facial muscles to say things. Meanwhile, in her British accent, she doesn't has to move much muscle. So I think that's something very significant in this. So people with some accents in which they don't open their mouths or they don't move their mouths much while speaking. In that scenario, it might lead to not being able to understand. I'm pretty sure some people are very expert at reading those the lips too, but it's going to be difficult for normal people. Okay, so we're going to close this for now, and let's see what else is going on. AI chatbot, physics and AI model plots collaborate to prove 10-year-old jamming. Okay. Right. And World Cup research reveals strategy to give teams penalty. And this is, uh, bruh, every time. One of the football's most iconic moments, penalty shootout. So we do not want this. One of the football's most iconic moments, the penalty shootout, may be far more strategic than previously thought. Bro, we know it. Penalty shootouts are obviously like they are. If a match is reaching penalty shootout, yeah, it's sometimes it's boring when they don't, and most of the goals are not there. Or it's just me that doesn't like when there is no goal and the goalkeeper stops them. But it's very significant. With new research challenging the notion that team kicking first holds them. Okay, of course, if first team is has in the first penalty, the first team goals. The second team obviously has a pressure. It should be obvious. Na? Who shoots first matters, but not in a way. Okay, I am thinking that it matters because the second one gets a pressure. What are they thinking? First shooting doesn't magically make better penalty takers, but it does force the other team to confront more moments when single mistake All the success bounty. In only 60% of penalty kicks were converted when missing meant immediate elimination, compared to almost 90% when penalty could immediately win the shootout. Oh, okay. So they are saying basically that if you're if you're in the condition where you might lose, you're more likely to they are more likely, not me, I am not playing football at that level, but I don't even play football actually. But if you're about to lose, you are less likely to miss than you, and you are more likely to miss if you can win. Basically, winning motivates people less to get to be more focused, and losing, people really hate losing. They hate losing more than they like winning. That's a society thing. We cannot do anything. What else? What else? What? Oh, okay, we have to go back. Okay, let's do new research in what field we should go for? What field we should go for? Chemistry. I hate chemistry. I hate studying chemistry. But since we are not exactly studying it, we're just having a discussion. Why not? Chemistry. Hot topics in chemistry and materials. Okay. Okay. So there's so many types of chemistry: tumors and cancer, mechanochemistry. And guys, either you want me to go into any one of them, I don't want to go. If I'll wait for anyone to type anything. No? Okay, then we'll not. Uh, hmm. New research in what do we say? What do we search? Chemistry, maths, sociology. See, sociology is very important. Okay, many of them think, it's an art subject, it's a humanities subject, it's something people who don't want to study. But no, sociology has a great impact on the mind, okay, of the people. Like you might have heard scientists have found that the more people do this, although who do you think they do? They're not. These researches are not done by physicists or mathematicians. Mathematicians sometimes do, but only from a numbers point of view. Uh, the contextual research is done by sociologists, so it's a field that is, I feel, less respected and underrated. Frontiers in sociology. This is a significant aspect of science, and we should definitely give more respect to it. Spatial differentiation and integrated tourism, development of China's traditional heritage village. The title itself is so reveal it shows how seriously we are taking these things, how serious topics we are discussing. So no, sociology is not just a time pass subject, it's a very serious subject. Diversity in energy transition in multi is okay. Hmm. Okay, we have less people right now. It's fine, it's fine. See, this is how a community grows. We start out low. We we keep discussing, we keep be consistent, and more people start joining. Okay. So uh, right now what's the time? Okay, 50. 10 minutes. Let's talk 10 minutes more and then we'll wrap it up. And in the quicksand, suspended lives of non-returnable migrants in Italy. Military service and entrepreneurial intentions, the impact of service tenure and tactical something more relative. These kind of things are not relatable right now. Recent publications, top. Let's take top downloaded articles. Hey, Titus school outcomes of children raised by same-sex parents. Theory of radicalized organizations. Hiring as cultural matching, the case of elite professionalism. Okay, abortion and women's future. Let's see this school outcomes of children raised by same-sex parents. These kind of websites um, ask for verification so many times, right? I'm not even using VPN. It happens when you're using VPN, but reject non-feature. School outcome abstract. Although widely used in policy debates, literature on children's outcomes when raised by same-sex parents mostly relies on small selective samples. This has led to lack of statistical power and an inability to distinguish children born to same-sex parents from children separated of parents. Children of separated parents. Oh, that makes sense. Okay, so we address these issues by using unique administrative longitudinal data, blah blah blah. Which first these data include 2,971 children with same-sex parents. Okay, that means same-sex parents and okay, 2,780. Very few gay male couples they have picked up as sample size. Maybe the number of gay couples is less, I guess. And over 1 million children with different sex parents followed from the birth. That indicated children raised by same-sex parents from birth perform better than children raised by different sex parents in both primary and secondary education. Our findings are robust to use of cousins, fixed effects, and quotient exact matching to improve the covariate balance and to reduce model dependence. Further analysis using novel bounding estimator suggests selection on unobserved characteristics would have to be more than 3 times higher than the selection of observed characteristics to reduce the positive estimates to zero. Basically, gay people are raising more academically better children. Can we generalize this? I don't know. I mean, they have published a research, but that this kind of why you guys see this is the paper by Sage Generals and School Outcomes of Children Raised by Same-Sex Parents, evidence from administrative panel data. So if you guys make want to read in detail about this, okay, you know what we searched. We searched new research in sociology, and then we click the page of Sage Generals, so you know where to find it. And please comment if you read it in detail because it is very interesting. Theoretical perspective, data sample construction, that's something very new. Okay, and other researches. Let's just read the titles. Marriage and masculinity, male breadwinners culture, unemployment, separation risks in 29 countries. Now, these are the researches that actually impact a society. See, the actual goal of this discussion is that the more informed we are, the more informed discussions we have, the more likely we are going to address the problems our society have. Okay, so please join in the live stream and comment your opinions, your ideas in the chat, live chat, or even after the video is published. Please uh, put your opinions on the in the comments, and let's just build a community where we discuss the things seriously, right? Because it's very important. We have more and more communities that discuss important topics, right? So okay, so we'll uh, I think conclude here now, and not many people kind of joined us, but it is fine because this is we are still starting out, and I'm sure at more and more people will join over time, and we'll have more people, presenting their ideas. But meanwhile, I would like you guys to, even after this video is posted, I would like you guys who are watching this video, please, if you're interested in any of the articles we discussed, read them, tell me something more about in details about that content, and I'm pretty sure that once you write in comment, more people will have an opinions, and that's how a communication happens. That's how a community is, you know, that's how a community is built, where people, where ideas are shared, where discussions happen, right? So and please subscribe this channel, like the video, so that it helps us, it helps me to come back to you guys and bring more and more discussion ideas with you. And the main thing I want to do is that I want to come and have a genuine conversation. This is not something that just gapping and all, but I'm fine with having nice conversations with you. So please subscribe it, and subscribe the channel, and share this video to your friends, and I'll start scheduling the streams, and mostly every day I'm going to come here 9 o'clock. So if you guys are interested, you can come to the channel after subscribing, and I'll be there at 9 o'clock. Until unless I'm not here, I'll probably update you guys on the channel itself that I will not be able to join. But most likely on 9 o'clock to 10 o'clock, I'll be here. Let's have a regular discussions, because see, it's very nice to see sometime discussing things, but change only happen when we are consistent with our ideas discussion. Because if discussions are not happening regularly, the it's difficult to build upon them, right? Because after some time, most of the people forget what have been discussed, and then we have to rebuild that conversation again, and just waste time, energy, and nothing really actually happens, right? So also share your opinion, also share the ideas, what new researches we can. Right now we just went through many researches on the surface level, but it would be a great idea to dive deep in any topic if any of you guys suggest something. So okay, I'll be taking the leave, and let's meet tomorrow. Peace out.